So today's video is a bit different. It's just going to be me going through these multiple choice questions, 7, I think, or 8. These are exit ticket questions because my teacher assigns them to me at the end of the class. 1 usually, or 2 depending on how much time you have. Anyway, let's go on with this video. So question 1, well, I know it's just a single solution being added. I can find out the concentration of H plus ions very easily just using this simple formula or equation. Let's get rid of that. So concentration H plus equals 10 to the power minus 2.50. I don't need to calculate that out just yet, but how do I find out Ka? Well, Ka is H plus A minus over HA, but in this case, just because we've just added only a solution of weak acid, we can assume HA is equal to A minus, therefore is H plus squared, concentration H plus squared divided by HA, so it's going to be 10 to the power minus 2.50 squared divided by 0.100, and you should get 1.00 times by 10 to the power minus 4. Question 2. Okay, now this one looks very intimidating because, you know, already 2,4,6-trichlorophenol, like, that is just such a, you know, not a very pleasant way to start the question with such a big molecule with so many chains. But it's a weak monoprotic acid, so it only releases 1 H plus ion per molecule. With Ka, that temperature, that was concentration of hydrogen ions in that much solution of that. Okay, so Ka is obviously H plus A minus over HA, but in this case, all we've added is so what we can say is Ka equals H plus squared over HA. So K, what we're trying to find, concentration of hydrogen ions. Yeah, so I'm not trying to find pH. So H plus equals square root of Ka times by concentration of HA. And I can just substitute the values in. Ka is 2.51 times by 10 to the power minus 8 times by HA, which is that. And it's monoprotic, so we don't need to times it by anything. Well, I guess you could times it by 1, but it's just going to be the same anyway. So we get 2.51 times by 10 to the power minus 8 times by 2.0 times by 10 to the power minus 3. 7.085 times by 10 to the power minus 6, so the answer is B, 7.09 times by 10 to the power minus 6. Question 3. Now this one, okay, which statement is correct? So this one's a bit. Which statement is correct? Propanoic acid is a stronger acid than butanoic acid. The value of Ka for propanoic acid is greater than that for butanoic acid. The value of Ka is that, and value of Ka for butanoic acid is that. So what is Ka? Well, Ka is obviously, there's multiple equations for it, but in this case we're going to use Ka is 10 to the power minus pKa. So let's find out Ka for this and Ka for this just by doing 10 to the power minus pKa, 10 to the power minus 4.87 for the first one, 1.35 times by 10 to the power minus 5, and it looks like we've got a correct answer, but let's do the other one. 1.51 times by 10 to the power minus 5. The value for Ka for propanoic acid is 1.35 times by 10 to the power minus 5, and that is the correct units. So yeah, just by using this equation, Ka is 10 to the power minus pKa. Got the correct answer. Question 4. the acid dissociation constant, Ka, of a weak acid has Ha has a value of that. What is the pH of that? So Ka equals obviously H plus A minus over Ha. We can't find A minus, and we know it's a weak acid dissociation constant. So we can say Ka is equal to concentration H plus squared divided by Ha. And therefore H plus equals square root of Ka. I'm just trying to think, what is the Ka? Ka is the value that, okay, so that is the Ka. Yeah, okay. 2.56 times by 10 to the power minus 4. It's not, you know, extremely clear. Times by Ha, which is, yep, I'm guessing that. And then, yeah, obviously we are not done just yet. Can't get too excited, because now we need to substitute into pH equals minus log 10 concentration of H plus pH is minus log 10 of my answer, 2.98. And obviously remember, pH always should give it 2 decimal place. Question 5. Now this one definitely does not look easy at all, because of the, you know, the link between organic chemistry and now physical chemistry, but it shouldn't be too hard. It says this question is based on reaction compounds shown in the scheme below. Okay, a 0.100 mole per dm minus cube solution of X is found to have a pH of that. The value of Ka is, okay, so how do we do this? Well, Ka is H plus A minus over Ha. But we've only got one solution, so we can say Ka is equal to H plus squared divided by Ha. Okay, it's really not that. It's not extremely difficult. Never mind. Ha. We know Ha is that of X. Well, it's got to be that, because it can't be H plus, because to find H plus is 10 to the power minus pH. That's what they gave us, the pH. H plus equals 10 to the power minus pH. Concentration H plus equals 10 to the power minus 2.50. So I can say it's 10 to the power minus 2.50 squared divided by Ha, 0.100, and that should give me Ka. So brackets 10 to the power minus 2.50 squared outside the brackets, and then I also need divided by 0.100. 1 times by 10 to the power minus 4. 1.0 times by 10 to the power minus 4. Therefore the answer is C. Question 6. This question refers to the reaction sequence below. HCN is a weak acid with a pKa value of that. If a 0.010 mole per dm minus cube solution of HCN was used in the first step, the concentration of cyanide ions in mole per dm cube would be, okay. So obviously we're going to use Ka is equal to H plus. Now divided by Ha. Now is it H plus squared or H plus A minus? That is the first step to identify. Well, I know that a 0.010 mole per dm minus cube solution of HCN was used in the first step. The concentration of cyanide ions would be, well, where's the cyanide ions? The cyanide ions is actually, let me just do this one. Ka is 10 to the power minus pKa. That's pKa. Ka is 10 to the power minus 9.40. So at least I've got, you know, one calculation done. Now for this, well, I know 0.0100 0.010 moles per dm minus cubic solution of HCN was used in the first step. Concentration of cyanide ions. HCN, concentration of cyanide ions. Cyanide ions. HCN was that. Concentration of cyanide ions would be what? I've got Ka, so that's out of the way. I know 0.010 within minus cubic solution of HCN. HCN, so that is HA in this case. Concentration of cyanide ions. Now, if I do H plus A minus, well, I can't find out any of them because I've got two constants, two unknown values. But if I do H plus squared and times its final square root, I'll get the H plus ions. And then I can rearrange it to find A minus. I feel like that's the only way I can do it. I feel like. So H plus is square root of Ka 10 to the power minus 9.40 times by HA 0.010. That's H plus ions. Now to find out A minus, all I have to do is Ka 10 to the power minus 9. Let's put brackets 10 to the power minus 9.40 times by HA 0.010 divided by my concentration of H plus ions, and I get 1.995 times by 10 to the power minus 6, so I get it's going to be 2.0 times by 10 to the power minus 6. If this is correct, I'm actually going to be very happy, because I can see you guys could clearly tell I was clearly struggling with this question, but that's exactly why I need to do that question. Question 7, hopefully it might be the same as the first question. This question 6 is very hard. Question about following reaction scheme, which was preparation of polymer P. K is a weak acid. With the pKa of that, the pH of that of K is, okay, so I know Ka is 10 to the power minus pKa. Ka is equal to 10 to the power minus 9.95. Ka is H plus. Now, is it H plus A minus divided by HA, or is it H plus squared divided by HA? That's the question. It is going to be H plus squared divided by HA. It can't be H plus A minus divided by HA. So it's going to be that. And the concentration of H plus ions equals the square root of Ka 10 to the power minus 9.95. Ka, remember, is 10 to the power minus pKa times by HA, which is at 0.10. That will give me the concentration of H plus ions, which is not what we want. One second, let me first put in the calculator. We want the pH, obviously, and pH is equal to minus log 10 concentration of H plus ions. So pH is just going to be minus log 10 of my answer, which is 5.475, so 5.48. Okay, now let's mark them. Obviously, I don't want to try my best not to give you guys wrong answers, but question 1C, 1C, question 2B, 2B, question 3C, 3C, question 4C, question 4C, question 5C, question 5C, question 6A, yes, I actually got it right, and then question 7C, perfect. So got all of them right. That's pretty nice. And obviously question 6, was the one I struggled with the most. It's just a lot of information, you know. They give us a pKa, well actually not a lot of information, that, and then he was asking for concentration cyanidines. I should have known that I could find out H plus and then substitute it in to get A minus by rearranging it. And that is the end of this video. Hopefully you guys found it useful.